Hello, everyone. Happy New Year. My name is Claire McLean, and I am recording a quick video to share our research highlight for this month. It is another oldie but goodie. One of the most common questions that I get asked is when I'm doing exercise, how is it helping? What is it actually doing? And I think the science underlying and the biology underlying what happens when we exercise and how that's beneficial for Parkinson's is really cool to hear about. And for me, it's very motivating, both for myself to do exercise and also to, share that information with our members because hopefully it will motivate them as well. So I'm going to share my screen and show this article for you, or show this article to you. So this article is another review. It was published in 2015, so it was a while ago. There's probably even more great data that would contribute to this, but I just love how they describe things. The title of the article is We Need to Move More: Neurobiological Hypothesis of Physical Exercise as a Treatment for Parkinson's Disease. It was written by a number of different professionals in exercise physiology lab, neuroscience lab, Center of Study and Research of Aging, physiatry, psychiatry, neurology, a real group effort here by Renato Monteiro Jr., Thais Savada, Bruno Oliveira, Eduardo Latari, Eduardo Portugal, Alessandro Cervallo, and Andrea Deslandes. I probably did not pronounce those names correctly, but I'm a big fan of their work. Apologies if I didn't pronounce it correctly. And just the abstract here gives a lot of good information. This is actually not a really long article, but just this abstract, I think, is very exciting and motivating. So they write, Parkinson's disease is one of the most prevalent neurodegenerative diseases in the world. The degeneration of dopaminergic neurons in the substantia nigra and chronic inflammation impair specific brain areas, which in turn result in lesser motor control, behavioral changes, and cognitive decline. Nowadays, drug treatments are the foremost approaches in treating Parkinson's. However, exercise has been shown to have powerful effects on Parkinson's based on several neurobiological mechanisms. These effects may decrease the risk of developing Parkinson's by 33%. However, these mechanisms are unclear and little explored. Among several mechanisms, we propose two specific hypotheses. One is that physical exercise reduces chronic oxidative stress and stimulates mitochondria biogenesis, that is the creation of more mitochondria, and upregulation of autophagy. Autophagy is when the cells clear out all the toxic, misfolded proteins. So autophagy is a good thing. We want our cells to be clean in Parkinson's patients. Moreover, antioxidant enzymes, examples of superoxide dismutase, become more active and effective in response to physical exercise. Number two hypothesis is that exercise stimulates neurotransmitters such as dopamine and trophic factors such as BDNF, GDNF, FGF2, IGF1, among others, synthesis. So we make more of these trophic factors when we exercise. These neurochemical phenomena promote neuroplasticity, which in turn decreases neural apoptosis, that is death of cells, so we can decrease death of cells, and may delay the neurodegenerative process, preventing or decreasing Parkinson's development and symptoms, respectively. So to me, it's very exciting. There are things happening at the cellular level, and both kind of actually in the cells and then also in the chemicals that our brain makes that are necessary for it to be healthy. So just that abstract I find very motivating. They go through and describe, introduction, more information about Parkinson's. Then they discuss how, in this context, exercise has been shown to be an important ally in the prevention and treatment of Parkinson's since it has a neuroprotective effect, and people with better fitness levels show a reduced risk of developing Parkinson's. Do it all showed that older adults that performed moderate to vigorous exercise during their middle age or in the last 10 years before evaluation had a lower risk by 33% of developing Parkinson's. So it's always a great time to start exercising and keep going with exercise. According to these authors, one of the several mechanisms related to Parkinson's prevention is brain volume associated with physical fitness. So no matter what, exercising and having your brain be a bigger volume is going to be beneficial for you and for me as we age. Parkinson's patients undergoing physical training can also improve muscle strength and postural stability, fundamental physical qualities for patient functional autonomy, people being able to maintain their independence, do what they want to do, go where they want to go. The stronger you are, the better your balance is, the more you can live your life the way that you want to. Approximately 200 or 2,500 US dollars are spent annually on the purchase of drugs. And I would estimate that that probably is higher now, because the good news is many more treatments have been developed in the past 10 years, but those treatments do tend to be expensive. Anytime a new drug comes out, it tends to be more expensive. So that could definitely be higher. And then when someone has a surgery, it's closer to $100,000, which often is covered by insurance, but that is still at a great expense. And there may be some out-of-pocket expense to individuals as well. Thus, treatments incorporating exercise can be an effective and low-cost method regarding PD treatment perspectives. So then they said, though, that neurobiological mechanisms resulting from exercise still have not been fully elucidated. In this context, we want to talk about those two hypotheses. So physical exercise reducing chronic oxidative stress, stimulating mitochondrial biogenesis and upregulation of autophagy, and then the antioxidant enzymes become more active and effective, and also that physical exercise stimulates neurotransmitter such as dopamine and trophic factor synthesis. So those are very different mechanisms and both beneficial. So I'm not going to go through all the details. If you're interested in reading this full article, like I mentioned, it's not a really long article. I'll go through a couple more pages of it, but I think it's only like 4 or 5 pages long total. But if you are interested in reading more in depth about it, you can. So they talk about the details of oxidative stress and Parkinson's, evidence supporting hypothesis 1, the effects of exercise on oxidative stress. And here a complex image that I don't totally understand, but some of you probably do. I know some of you are scientists. I'm a physical therapist trying to take the science and implement it in the real world. Here, though, this image I can understand. So exercise as a key factor, aerobic exercise, strength training. When we work our muscles, we develop trophic factors. It also improves our mental health. There are acute effects, so that means short term, and there also is a chronic effect. So the longer you do it, that effect, that positive effect can build up over time. Acute brain oxidative stress increases ROS, and there is a chronic response to oxidative stress, mitochondrial biogenesis, transcription and translation, increased antioxidant enzyme activity. So I sort of understand, don't totally understand, but very good things are happening at the cellular level, at the chemical level in our brain. Then they go on to describe the evidence supporting hypothesis 2, exercise effects on neurochemical synthesis. So the chemicals in our brain are very important as well, such as dopamine and the trophic factors. So they describe that in more detail, and then they come to the conclusion. So exercise can trigger important acute and chronic biological phenomena that may aid in Parkinson's treatment. Physiological adaptations such as mitochondrial biogenesis and antioxidant enzyme activity as a result of regular training can support our first hypothesis, in which physical exercise reduces oxidative stress. In addition, moderate to vigorous intensity exercise training may potentiate neurobiological response, neurogenesis, angiogenesis, and synaptogenesis, more neurons, more blood flow to those neurons, more synapses, strengthening our second hypothesis, in which physical exercise provides maintenance of neuronal health and stimulates neuroplasticity. Both mechanisms can lead to higher patient benefits, such as improved postural balance and motor control. In addition, behavioral improvements can occur. So hopefully you hear that the exercise you're doing is not just good for your heart and your lungs and your muscles and your bones, which it is, but it's also positive for your brain. And there really is no treatment. There's no medication. There's nothing that does what exercise does for us. And it is accessible to you now. So whether you are exercising already and you realize maybe you could bump up and work a little bit harder or exercise a little bit longer or a bit more frequently throughout the week, maybe try something new. Or if you're not exercising now, hopefully this motivates you to get started with a program. Start with what you can handle. And the goal is to keep challenging yourself to build up the amount of time, the frequency, the intensity of the exercise. And if you need help doing that, You know where we are. You can send us an email or give us a phone call, and we'd be happy to help you get started or progress in your exercise. Or if you're interested in more information about this article, let us know about that as well. All right. Happy New Year, everyone. Let's make 2025 a really good year of exercise, unleashing our strength, achieving goals, and really seeing, if we dedicate ourselves to exercise, how much we can get out of it. I will be doing that as well. I am active, but I'm not really exercising as much as I would like to. And I'm going to take it up a notch this year, be more consistent about my higher intensity aerobic exercise, my strength training, my balance work. So I'm right there with you. And yeah, let me know if you have any questions or if you want to let us know how it's going. See you soon.